Now moved on to number 9. This is the start of chapter 8, which is looking at the circles. So in number 9, we have QR is a radius, PQ is a tangent, and we need to find what the length of QR is. So let's just throw an X for that. We know tangent and a radius are perpendicular, so what this really becomes is a Pythagorean theorem problem. We go 25 squared equals x squared plus 20 squared. Gives me 625 equals x squared plus 400. That becomes 225 equals x squared, so x is 15. So our radius is 15. 9b, we need to find UW. And what we first need to do is notice that these are congruent chords. Since these are congruent, this arc is also 100. So I have 100, 100, and 130. These all add up to 330. Since I know the circle adds up to 360 in total, that leaves us 30 degrees for arc UV. 9C is we have an inscribed quadrilateral, and we need to find the measure of angle G. Whenever you have an inscribed quadrilateral, the angles opposite them each other are supplementary. So I'll do 75 plus the measure of angle G equals 180. Okay, subtract 75 from 180, and I get 105 for that angle. Wanted to check, 110 and this angle would make it 70 because those would add to 180. 9D, we need to find DEF, which is this arc out here. And this angle opens up to that arc, so I actually double it, and the answer is 200 degrees. But if I wanted to go through and check, and maybe they ask for a different piece, this would be 80 degrees, because it adds to 180 being a straight line. If I doubled that, it would be 160, which now the 200 and the 160 add to 360. So answer is still 200, but it is a way that we maybe have to solve it or check our answer. 9E, we need to find the measure of arc DF, which is right here. When I have the angle outside the circle, it's going to be big arc minus little arc divided by 2 equals the angle, but I have to make sure I get the setup correct. So it's going to be 22 equals 110 minus x over 2. 22 equals big arc minus little arc over 2. So now I'm going to get 44 equals 110 minus x. If I subtract 110 from 44, I get negative 66 equals negative x. And so x comes out to be a positive 66. In 9f, we can get to it a couple different ways. One way is to double the 28 to get this arc out here, which is 56. And then since this is a diameter, I can subtract 56 from 180. And I get 124. Then to find arc angle AMD right here, we take half of the 124, and it's 62. So that is our answer, 62. Another way is if you notice the 28 here, the 28 and the diameter actually make a right angle, so I could have just done 90 minus 28 and also gotten to 62 degrees. For 9G, we're going to use the inscribed angle first at 32. We're going to double that and go 64 out here. Then 156 plus 64 gives us 220. To find the leftover piece, I subtract the 360 minus 220, and I get 140 degrees. 9H, we're going to do the sum of the arcs, add the two arcs together, and that equals, add the two arcs together, divide by 2, and that equals the angle. So my angle is 103, and my two arcs are x plus 116. Got my setup. Multiply the 2 over, I get 206 equals x plus 116. I'm going to subtract, and we get x is 90 degrees. For 9I, I'm going to need to find the arc BKG. Well, I know this is half the circle, so this part is 180. In order to find this portion, since this is a central angle, I put the 84 out here. 180 plus 84 equals 264 is the measure of arc BKG. It's a major arc, so remember for that one. 9J is like 9E, which we've done already. We need to do big arc minus little arc because I have a big portion. and the little portion. Now the little portion is 95. If I subtract that from 360, I get that the big portion is 265 because all the pieces are taken up. There's not a part that's not included. So I'm going to do x equals 265 minus 95 over 2. I get 170 over 2, and my answer is 85. Now for 9K, it's the angle on the inside, so I'm going to add the arcs. So it's 172 plus 78 over 2. 172 plus 78 is 250. Divide that by 2, and I get 125. For 9L, I have the 4, 6, 3, and x. I'm going to multiply the parts of the same line together. So that's 4 times 6 equals 3 times x. That gives me 24 equals 3x. Divide by 24 by 3, and I get an 8. 9M, I'm going to move the x to here. It is a radius. I can move it wherever I want as long as it maintains being a radius. And take half of the 16 and make it 8. In doing that, I have x, 6, and 8. So x squared equals 6 squared plus 8 squared. Being a right triangle, I can use Pythagorean theorem. X squared equals 36 plus 64. I get x squared equals 100, so x equals 10. In number 9n, it's 2 secants. So my rule here is to multiply the outside part times the whole thing of one line equals the outside portion times the whole thing of the other line. So my top line is 5 times 14, because that's 5 and 9, and then 6 times 6 plus x. So I'm going to make this 70 equals 36 plus 6x. I do 70 minus 36 gives me 34 equals 6x. Gives me 34 over 6 after I divide, which gives me an answer of 17 over 3 once I reduce. For 9O, it's still going to be the same thing with the secant. It's the outside, 5 times the whole thing, which is 8. But now the tangent, I make it tangent squared. So that's x squared. I get 40 equals x squared. X equals the square root of 40. We can look to simplify that because that is 8 times 5, which is 4 and 2. So I actually get a pair of 2's. So I'm going to write this as 2 root 10. 9P, our angle is 60 degrees and our radius is 12. To find the area of the sector, I'm going to do the fraction of the angle over 360 times my formula for area, which is pi times 12 squared, or pi times radius squared. So this is 1/6 times 144 pi. If I divide 144 by 6, I get 24 pi. And that's going to be centimeters squared. That's my answer for O, or I guess that's P here. That's the area of the sector. Then the length is going to be the angle over 360 times the circumference, which is 2 pi times the radius, which is 12. So now it's 1/6 times 24 pi, and the length would then be 4 pi centimeters. Let's go through and check some answers off here. The area of a circle is area equals pi r squared. That is always true. The measure of the central angle is half the measure of the intercepted arc. Central angle and the arcs are equal, so that is never true. Circles are congruent. Sometimes it's when the radius is the same, or the radius is equal. Circles are similar is always because you can always write a ratio between the area or the radiuses to represent like a scale. Is it twice as big as 3 times as big? They're still similar because they're still circles. The interior angle of a circle is half the sum of the intercepted arcs. So we're saying there is if you had an angle and you took both arcs, you would add them together, divide by 2. That is always true. Two diameters divide a circle into 4 congruent arcs, each with a measure of 90 degrees. That one could work if it was like this, but we could also have one when they're very close together and it wouldn't necessarily be 90 degrees. So we're going to put a sometimes there. And the opposite angles of a quadrilateral inscribed in the circle are supplementary. Opposite angles are supplementary, so we're going to say always true.